Alright, hi class. Oops. So I decided to make one more short video just to finish up chapter 13. There's a few topics that we are not going to be able to get to, but I wanted to explain them to help you understand them more than just reading them in the book. And the last type of renewable energy that you actually will see in the movie that we do on Friday is called tidal energy, which is pretty neat. And as you can imagine, it relies on the ebb and flow of tides to generate electricity. So basically, ocean water coming in and going out is a way to generate electricity, the movement of that water. And there are two ways that this can work. The first one is kind of manipulating the water in the ocean so that it works kind of like a dam. And what that means, and you can see in this picture here, let me see if I can get my pointer here. Okay, so in this picture, you can see that there's this wall. And what happens is the water, as the tide goes up, the water goes through these holes and basically collects on one side of this big barrier. And this often happens in kind of, and it'll show you in the movie, but if you have some sort of inlet or bay, in this area here, I can't really draw this, but let's say this is all water, and then this is land, okay? The water is going to go into an area like this, and if you had a wall that was trapped on this side, or a wall that was like that, it would trap all the water, and the water would increase in height on this side of it, and you basically would trap it, and as the tide went down, you wouldn't allow the water to pass through. So these are kind of openings that you can open and shut when you want. And so all the water is going to go through, collect on this side, and remain high. As the tide goes down, you're going to create a gradient, a height differential, much like a dam. Okay? The tide goes all the way down, and once you get the maximum height differential, you open up these turbines, and essentially this area here is what is represented. This shows a cross section, and that's essentially what's in all of these. Okay, so there's a generator within each one of these, and as the water rushes through, and it's rushing through just like it happens in a dam because of this height differential, you're going to create electricity. So that's how tidal energy works. Kind of one problem with this, and it's good, you know, because it's renewable and you're not creating any CO2 emissions or anything, but you can imagine there's a lot of stuff living in this water. So as you know, the water goes through, you're also having lots of animals and fish and invertebrates and stuff go through. So they're not going to be very happy about going through this generator and this turbine. So that's something to consider. Always have trade-offs. Okay, so that's one way. So it's basically tidal energy kind of working like a dam. And there are other types of tidal energy that work kind of like a wind turbine. And this uses energy from the ocean, and it kind of moves in all directions. So this, I really like this diagram as it's animated. And you can see that this would be maybe more in the middle of the ocean or not necessarily in an inlet like this. And the water moves to the right here and to the left here, and essentially you have some sort of turbine that's going to move as the water moves around it. So, you know, this is like a wind turbine because essentially instead of wind and air moving a blade, you have water moving a blade, and that is gonna be the turbine that generates electricity. So that's another way that tidal energy can produce electricity. Okay, and so the next thing that's in this chapter that we haven't talked about in class is a hydrogen fuel cell, and this is often used in cars, and it's the idea that you can generate electricity when hydrogen and oxygen react together to form water. Okay, so when hydrogen and oxygen come together to form water, that produces electricity. And what it relies on is the supply of hydrogen. We have oxygen, and this diagram here shows it. So if you have hydrogen coming in on one side and oxygen coming in on another side, they're going to react to form water, but also this reaction of the oxygen and hydrogen coming together produces electricity, and you can generate electricity from this. The oxygen that you use as the fuel is provided by the air, which is nice, but it turns out that the hydrogen, just free hydrogen molecules, are not part of our air supply. So you actually need to create those. And so it relies on as it mentions here, a hydrogen fuel supply, which we need to create. So we basically make a hydrogen supply through electrolysis, which is the name of the process that splits water. So it's kind of funny because in order to create a hydrogen supply, we split water and then we use that hydrogen to make water. So it's kind of a cyclical thing. And you're essentially using a battery to split water, and you attract the this shows the electrolysis here, and you have this negative electrode here that's going to attract the positive hydrogen ions, and then on this side you have the positive electrode that's going to attract the negative oxygen ions, and that's how you split it. It requires electricity to do that, and it turns out, of course, as you would imagine, that you end up getting more electricity out of the reaction when they combine than you do when you split them. And that's why it's profitable, and that's why you can use it. You can use them in buildings and also in cars. And the downside is that it is pretty expensive, and that you also do need to get this hydrogen fuel supply, which requires water. But you do get water, and most of the time when you're using this in cars, the water is in the form of vapor, so there's no CO2 emissions, which is another advantage. Okay, and then you also saw in your study guide this acronym NAECA, and that stands for the National Appliance Energy Conservation Act. And maybe you have seen these labels, these Energy Star labels, and this Energy Star label is essentially kind of what came out of this act. And what it did is it set national efficiency standards for all appliances. So there's some countries that really don't have this, and it's a problem because they can have refrigerators and old kind of washers and stuff that are really polluting, and as you guys saw from the lab we did, would use, when you plug it into the wall, they would use a lot of electricity. And because that electricity is hooked up to a power plant of some sort, most likely coal, as you know, that's going to cause more pollution, not from your home directly, but indirectly when it's connected through a grid to the power plant. So we now have energy efficiency standards for appliances, so when you go and buy them in a store, kind of like a car, they can't be too demanding in terms of their electricity use. And manufacturers have to provide these labels on all new appliances, which is really good. And it also helps people save a lot of money, which is a great benefit because, you know, as you'll see, as you saw when we calculated your utility bill, you have to pay for the electricity that you're using. So appliances that use electricity are going to be cheaper to use. And just along the same lines of saving electricity, and please, you do not need to memorize these, but this being an environmental science course, you should just know what how different really simple measures can really help in terms of saving electricity, like lowering your thermostat or shutting off electronics when they're not in use. And this is especially for electronics that stay on, like your TV or your VCR, or even your chargers. You can save many pounds of carbon dioxide emissions each year by doing this. Oh, and this didn't come out on my screen here. Let me escape it real quick so you can see. So for every house in the United States that replaced, if every house in the United States replaced one of those regular incandescent bulbs with a fluorescent bulb like this, the pollution saved would equal removing 1 million cars from the road. And so you can just see how what a big impact that we can have collectively just by doing a simple thing like replacing the light bulb in our home. And you can hopefully remember from the lab that we did that you saw the difference between the watt use of those two different bulbs, so you can maybe understand a little bit better why that would make such a big difference. Okay, and then 2 more slides. This one, again, it's in your book and also in the PowerPoint online, but I just wanted to point out, all the different things here. If you just, before the test, just read over these. I'm not going to reread them for you because you can do that on your own. But just read over them so you have an idea of the different ways that people can save energy in their home. Those are just things that you should know about. And then cogeneration is the last thing. And it's another, we just keep coming up with and finding new ways of being efficient, which is really great. And this is another way, and it's basically producing kind of the 2 types of energy, electricity and heat together. So let's say you have some sort of fuel input, whether it's coal or natural gas, and you get electricity out of that. You're also, as you hopefully remember, you're also getting a lot of heat, whether it's for the exhaust from the gases or the production, like when you're burning coal or when you're burning natural gas to boil that water, there's a lot of heat that's also released, not just that's going into water. And so this cogeneration is actually generating either additional electricity or heating buildings from the heat that's produced. So that is a really good way of saving energy, because you're taking heat that's being produced anyway when you're producing this electricity and using it to heat buildings. I remember one of my dorms actually in college was really remember they made a big deal about it because it was cogeneration. We were right next to a kind of a facility of, I can't remember exactly what it was, but we were right next to this other building that was producing electricity, and our building was heated from the kind of leftover heat from that electricity production plants. So it wasn't a power plant, but they were producing a lot of electricity there, and we got the heat kind of left over from that. So that was kind of a great way of saving energy. All right, I believe that's it. All right, good luck studying, and I will see you on Monday or Friday if you're watching this on Thursday. All right, good night.